Alright, welcome to Moving Man, Part 3. This is problem number 4. Moving man starts at a position of x equals 8 meters and travels with an initial velocity of negative 8 meters per second and acceleration of positive 4 meters per second squared. Draw the three graphs. So in this problem, we'll begin with where we started last time with the data for the velocity graph. And here's our time and our velocity. And we can see in this case that we start with a velocity of negative 8 meters per second. And that as we go along, as time increases, the velocity changes at a rate of 4 meters per second every second. So if we change our velocity by positive 4, this then becomes negative 4. Then 0, and then a positive 4 meters per second. If we continue on, we go up to 8 and so forth. Alright, so we can see that in this case, the man is traveling in the negative x direction. At this point, the velocity is momentarily 0, and then afterwards the velocity becomes positive, which means the man turned around and is traveling in the positive x direction. If we graph this data right here, we can see that the initial velocity is negative 8, and we know this data is linear. So we graph it. It looks like this. There's our velocity versus time graph right there. This is 2 seconds and negative 8 meters per second. We talked before about the fact that the slope of this graph is acceleration, and that the acceleration should be positive 4. If we look at it, we can see the rise is a positive 8. The run is a positive 2. If we find that slope that is a positive 4 meters per second squared, that acceleration is constant, which means we can go ahead and graph that very easily. Just like that. A constant 4 meters per second, 4 meters per second squared. Alright. Once we have these two graphs, we can work backwards and go ahead and find the position graph. We know that the slope of the position graph gives us velocity. So at the very beginning, we can see that the slope is going to be negative because the velocity is negative. And we can also see that the problem starts at x equals 8 meters. So we're going to start up here at 8 meters. The velocity is negative, so therefore the slope is negative. The slope is going to be something like that. We can see that right here at 2 seconds, the velocity is 0, which means the slope of the position graph will have a 0 slope. And past 2 seconds, we can see the velocity is positive, which means our slope is also going to be positive. So the graph looks like it's going to be some type of upward facing parabola here. To get a little more exact though, we can, from the velocity graph, we can tell that in the first 2 seconds that the displacement is the area of this part right here. So displacement is 1/2 the base, which is 2 seconds, times a height of negative 8 meters per second. And that right there comes out to be negative 8 meters. So at 2 seconds right here, 2 seconds, we can see that we start at 8 and we travel in the negative x direction 8 meters, that we end up right here at the origin. And we talked about how the slope at this point is 0. So this graph looks like it's going to kind of form a U shape like this, bottoms out right there, and it continues up at the same rate right there. And that is our position versus time graph. Once again, the slope at this point right here, if we take this point, if we draw a tangent to that point, draw a tangent line, find the slope of that line, that would determine the velocity at the same time. At this point right here, this velocity right here, at this point in time, would equal the slope of this graph right here. We can also tell from the acceleration graph, we talked about the fact that the area of this graph tells the change in velocity. So let's look at the first 2 seconds here. The first 2 seconds. If we look at that area right there, we can see the area is going to be 8 meters per second. So that area represents a change in velocity, which is going to be length times width, which is 2 seconds times 4 meters per second, which gives us a positive 8 meters per second. And if we look at the velocity graph right there, that in the first 2 seconds the velocity does change by a positive 8 meters per second. So that matches up. So everything should be consistent, and so far we found that it is. Last but not least, it says how far did the moving man travel for the first 2 seconds? I think we figured that out already, and that was basically it traveled 8 meters, but in the negative x direction. And what was his displacement for the first 4 seconds? Well, the first 4 seconds right here, this graph looks pretty darn symmetric right here. And if we were to find this area right here, we can see that this area will be the same as that area over there. That this area right here would be a positive 8 meters. So therefore, in the first 4 seconds, it appears that he traveled in the negative x direction 8 meters, stopped, and then traveled in the positive x direction 8 meters. So therefore, the displacement at 4 seconds would be 0. All right, hope this helps out. Have fun.